Okay, so now, again, as I was trying to say earlier before the break, a lot of this stuff I don't think is that hard because I think you can figure it out. So what do I mean by that? I mean, let's look at the special parallelograms. We talked about a rectangle. Now we have a rhombus and a square. All right, and what's true about a rhombus and a square? Simply the rhombus, all sides are equal. So is a square a rhombus? Yes, a square is a rhombus. Is a square a parallelogram? So all the properties of parallelograms apply to the rhombus and to the square. What makes a rhombus a square? What makes a rhombus a square?
Aren't like all the sides and congruent and all the angles are congruent?
Yes, and what do the angles measure?
90?
Yes, that's the difference between a square and a rhombus. A square, the angles are all 90 degrees. A rhombus, the angles don't have to be 90 degrees. So every square is considered a rhombus, but not every rhombus is a square. Hopefully that makes sense. All right. So now let's look up here at this rhombus. All right, so when you're looking at this rhombus right here, the first thing I would do if I was making a rhombus would mark all the sides congruent. All right, just like they have them. All right, and this is what I'm trying to tell you about when you take your test. Some of you are memorizing things. All right, and other of you are doing what I'm asking you to do, which is to think about things. All right, so those are equal. All right, now, what's true in a parallelogram about the diagonals? What's true in a parallelogram? Who can remember? First of all, are those diagonals equal?
Yeah.
Do they look equal? Let's start with that. Right, so let me try to draw something that will help you understand what I'm talking about. I'm trying to make, if I ever had trouble, I would try to make a rhombus. That kind of looks like a rhombus, would you agree? So when you exaggerate, all right, now if you draw the diagonals. Oh, if I draw the diagonals, even though I missed that one. Now, does everybody understand what I'm saying? Are the diagonals equal now? No, they're not. As soon as you tilt it, one diagonal is getting what? Longer and one's getting what? Right. So the more I tilt it, does everybody agree with that now? Right. So that's what I'm hoping you can do when you take your test is if you don't remember all the rules, you try to create the rules. All right. But now if you look at that, what's true about the diagonals? Yeah, they bisect each other. All right. So this is how I learned all of the geometry. All right. There's just no way I could remember all the rules for all the shapes. All right. So once I realized that they bisect each other, then I marked this equal to this and this equal to this. Does everybody see that? So now what's true about all four triangles that were created? They are all congruent. That is exactly correct. They are all congruent. All right. So now what you have to do is you have to look at each individual triangle. And what I'm trying to show you next is when you're looking at this triangle right here. All right, when you're looking at that triangle right there, and I'm looking at the and I'm trying to look at this triangle up here. I need to calculate the corresponding parts, right? Does everybody see, since you said that the triangles are equal, that this angle right here has to be a right angle, this has to be a right angle, and that has to be a right angle. Would everybody agree with that? Right, because they're equal, right? Therefore, those angles have to be equal. Now, my question, on the green triangle, what corresponds to H? M, right? And what corresponds to this O? All right, so what you're trying to see is that the triangles are kind of twisted, correct? Besides the fact you would know that M is congruent to this because they're alternate interior angles. Everybody agree with that? And then you can say this angle over here is congruent to this angle over here. So that would help you understand that they're twisted. Does everybody agree with that? Now, does everybody and again, I'm really trying to show you how we can tell now that the top triangle is definitely congruent to the bottom triangle, and the right and left triangle are also equal, but all four triangles are technically equal. Does everybody agree with that? So now that you know that, we can say that this angle right here is equal to this angle right there. Does everybody agree with that? These two angles here are congruent. This angle right here and this angle right here. Does everybody agree with that? If you're just looking at the corresponding parts. Now, another way to look at that is this, guys, because some of you are not still talking to me. So I will demonstrate differently. All right, let's look at this right here. Does everybody see that's an isosceles triangle? So that's what I'm trying to show you. This now has to equal this. Does everybody agree with that? And then these are equal to this over here also, because those are alternate interior angles. I'm just trying to show you how easy it is to calculate that the diagonals of a rhombus bisect the angle. This MH bisects this. Does it do that on a regular parallelogram that's not a rhombus? Do the diagonals bisect the angle in a parallelogram? Nowhere does it say that. Is everybody with me on this? All right, but anyway, all right, those are just all the different techniques that you could use to remember all of these rules. All right, I hope I'm making a little bit of sense, at least to someone. All right, so the diagonals of a square and a rhombus are what? Perpendicular. Always true. The diagonals of a rhombus and the diagonals of a square are perpendicular, and each diagonal bisects the opposite angles. All right, those are the two major things, the major difference. All right. Anybody have any issues? All right. So now that we've discussed all that, we can say simply the conditions for a rhombus and a square. If the diagonals of a parallelogram are perpendicular, then it's a rhombus. If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So all you have to do is check for one diagonal. You don't have to check for both. And if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. And if a quadrilateral is both a rectangle and a rhombus, it is a square. Does that make sense? Hopefully. All right, so those are all the things that you're supposed to know, all right, and kind of remember for the test. But as I was trying to tell you, to me, it was just about drawing a rhombus and looking at the shape and determining that all that is true. All right, hopefully that makes sense. All right, so now let's come down here. Here's my quadrilateral, and they're saying it is a rhombus. All right, so if it is a rhombus, then we can mark this. And what's true about the diagonals? They are what in relationship to each other? No, the diagonals are definitely not congruent. They definitely bisect each other. And they are perpendicular. That's what I'm hoping everybody will tell me. So when somebody draws a rhombus, this is what you should be doing. And once you do this to the figure, I think it's easier to answer the questions. All right, now you're going to come over here and you're going to say this is equal to that. And you should come down here and say these two, those angles are definitely congruent. And then these angles right here are congruent. And these angles over here are congruent. Right. And does everybody remember the opposite sides or opposite angles of the parallelogram are congruent, correct? So that's what I would mark anytime someone would give me a rhombus. I would just mark all that true. All right, and once I did that, then it was easy to answer the questions. All right, so let's see if it's easy to answer these questions now that you know that. So help me find ABD. If ABD is 60, then what is BDC? 60. Does everybody understand what I'm saying? Like, it's so easy if you mark the figure, all right, and the relationship. And the other thing I need, if you got all this, you think it's easy. For those of you guys who are thinking about it more, I would like for you to say that all four of those triangles now are all congruent. All right. Hopefully you're understanding that. All right. So we said this is 60 degrees. All right. Now, AE is 8. If AE is 8, what is AC?
16.
Yeah, come on, guys. Now remember, you got a lot on the line on this next test, a lot. All right, please don't wait, all right, until Thursday before you start getting your pieces together here. If AB is 26, if AB is 26 and BD is 20, how am I going to find AE? Somebody tell me what BE is. 10. So how am I going to find AE? Yeah, thank you, whoever said that. That's exactly right. A squared plus B squared equals C squared. Which one is the hypotenuse? Yes. All right. Now, the other thing I want you guys to write down is this, and we're going to write it down a bunch. All right. I want everybody to write down 3, 4, 5. These are called the Pythagorean triples. I know we've talked about it before. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. If you know those, all right, if you know those, life is easy. All right. So if I ask what AE is, how did I know that it was 24 without doing any work? Someone tell me how I know AE equals 24. Take a look at my numbers here, 26 and 10. Look at this guy right here. It's a multiple of what? What can I multiply each side by? 2, right? So 5, 12, 13 is the same as 10, 24, 26. Is everybody with me on that? Do I have to know that? No, I don't have to know that. Right? We can just come down and do the work ourselves. We can say A squared plus B squared equals 26 squared. So 10 squared plus B squared equals 26 squared, which is what, 676, someone tell me. Subtracting 100, b squared equals 576. So I think b is 24. All right, does anybody have their calculators? Everybody checking me on that? Make sure that's good numbers. Anybody have any issues with that? Anybody have any issues? Pythagorean theorem, kind of easy. All right, but these are super helpful for people who take standardized tests. All right, they're always there. All right, so now we know AE is 24. All right, let's take a look at CEB. What is CEB? Yeah, see how easy it is if you just mark your figure. Okay, now if CBD is 58, CBD is 58, what is ACB? What is it?
32.
Is that right?
Yeah.
I'm not sure. All right, I'm not, some of you guys now, like I said, some of you are saying it's 32. All right, and if you don't know it's 32, now's the time to speak up. So let's look at angle CBD. Let me find that. CBD is 58. Do we agree? So I'm coming up here and I'm going to write 58 down and you tell me if you're happy with that. So this is 58 right here, correct? This guy right here is 90, right? So I'm just going to put right over here, this is 32. Everybody seeing this? And again, if you want to, we could just make that 58, we can make that 32, we can make that 32, make that 58, that's 32. Everybody see how easy that is? And how did we get the 32? Well, we know the triangle angles add up to what? 180. If one angle is 90, that means the other two angles have to add up to what? 90. So 90 minus 58 is 32. Anybody have any issues with that? All right, let's go next. So AE is 3x minus 1 and AC is 16. So what is X, guys? X equals 3. I like that. Without doing any work, you just tell me the answer is 3. Does anybody have a problem with X being 3? Come on now, don't sit there. If you don't know why it's 3, you can tell me. Everybody's good with X equals 3? Simple. All right, let's look at the next one. Let's find CDB. CDB is this guy right here. I'm going to call that 6y. And then ACB is 2y plus 10. Is that right? All right, so somebody help me. What am I doing? Yes. How did we get that?
It's like half of it, so I did 3y equals 2y plus 3.
Say that again now. You know it's half. What does that mean?
So another thing is like half of the other,
But you're not telling me which one you're talking about.
like C, the ACB is half of CB.
So what's this angle right here? What's the, yeah, what? Yes, I'm not, like I said, I just wasn't sure if I was on the same page. This is 2y plus 10, right? So now what equation did you use?
3y equals 2y.
Oh, wait a minute. No. That's kind of a coincidence, I think. Somebody else tell me. What?
I did an 8y plus 10 equals 90.
Yeah, these two together, this angle right here and this angle right here add up to 90. You with me? Make sense? All right, that's why I ask you sometimes just lucky that it came out to be the right answer, correct? Right. So that would be 8y plus 10. Oh goodness, my pen is just miserable. 8y plus 10 equals 90. Everybody good on that now? So everybody can tell me it's just y equals 10, right? All right, I'm pretty happy with that. Anybody else? All right, last one here. So AD is 2x plus 4. So what's true about that, Tanner?
X equals 4.
What is it? What's true, Tanner?
That AD and CD are equal to.
Yeah, AD and CD are equal. AD is equal to CD. So what was X in this case?
4.
Anybody else get X equals 4, or everybody else, I should say, get 4?
Yeah.
Any issues on that? Okay. So now, given each set of vertices, determine whether ABCD is a rhombus, a rectangle, or a square. All right. So there's lots of ways to do this. All right. Now, if the diagonals are perpendicular, then it's a rhombus. Does everybody agree with that? And if the diagonals are congruent, then it's also a what? Square. Is everybody with me on this? All right. I kind of feel like that's the easiest way to do it. So if I'm looking at A, B, C, D, what are the two diagonals? I don't feel like drawing it out. What are the two diagonals? If I say A, B, C, D is the rhombus. What is it? Yeah, come on now. We're looking for AC and we're looking for BD. Now I need the slopes, first of all. I need the slope of AC and I need the slope of BD. Now we've done slope a million times, so someone tell me slope formula again. Change in y over change of x. That's what I like. Delta y over delta x. All right, so everybody's calculating the slope of AC, please. Is that 0?
Yeah.
Well, that's annoying. And what's the slope of BD? Yeah, no slope, right? So are they perpendicular? Yeah, they're perpendicular, right? So it's either a rhombus or a what? It's either a rhombus or a square. Does everybody agree with this? So now we need AC, the length of AC, and I need the length of BD. So what's the distance formula? Well, yes, but let's talk about the distance formula. What's the formula? X2 minus X1 squared plus Y2 minus Y1 squared. And those of you guys who looked at it and said it's vertical or horizontal, I'm okay with that, but I still need you to know the distance formula, Y2 minus Y1 squared. So what is AC? Someone tell me. 4. Do we agree? And what's BD? Yeah, I feel like, guys, we should just be able to mentally do that, right? 0 minus 4 squared plus 2 minus 2 squared. 4 squared, square root of 4 squared is 4. So number 9 is definitely a what?
Square.
Definitely a square. All right, let's try 12 just for fun. Let's see what that is. So I still want to check out the slope of AC. And I would like the slope of what? Thank you, BD. All right. Someone new, calculate the slope of AC and the slope of BD. Hello, I'm waiting. What? Somebody said the slope of AC is -1/8. I don't know if I agree.
Thank you.
Is that true?
That's very true.
Okay, so now let's do the slope of BD. What is the slope of BD?
7/4.
What is it?
7/4.
Everybody's agreeing with that? Correct? So is it a rhombus or is it a square? Or neither? Neither, right? So now we just have to determine, it says, determine if it's a rhombus, a rectangle, or a square. Right, so I'm assuming it could be a what? It could be a rectangle. So now we're gonna prove that it's a rectangle. Yes, Tanner, what's the matter?
How do you find the slope again?
What's the formula?
I don't know. I forgot.
Change in y, right? So again, m equals y2 minus y1 over x2 minus x1. All right, so now I need to find the slope of AB. I need to find the slope of BC. I need to find the slope of CD. And I need to find the slope of AD. And hopefully they're all negative reciprocals. So come on, somebody find the slope of AB, somebody find the slope of BC, somebody find the slope of CD, and somebody find the slope of AD. What's the slope of AB? What? 3/2. Anybody agree with 3/2?
Yes.
All right. Let's check out BC. What?
-1. Or no, that's not right.
Thank you.
-2 or 3.
Anybody else get that? So far, that's good, right? So what's CD?
Three over two.
And then AD.
It's -4 over -2.
What is it?
It's it comes out as -4/6 because it's.
So do we agree they're all perpendicular and parallel? And if they're all perpendicular and parallel, that creates a what? Rectangle. All right. So we definitely know this is a rectangle. Yeah, so Listen. Specifically, there's not a whole lot of extra work here. Hello, everybody's listening, right?
Yeah.
Because we have a test when,
Friday.
and you guys had a week off. So it might be good for some of you guys who really need to do well, and some of you really need to do well. It'd be a good idea to go back and look over 6-1, 6-2, 6-3, 6-4. Nothing strenuous. You should just be reviewing 6-1, 6-2, 6-3, 6-4. All right. Now I need you to finish 6-5 tonight. All right. If you didn't get a chance to finish because some of you went out where there was no internet, which I understand. All right. You still got to finish that up. All right. You got to finish up. All right. Anybody have any questions? All right. The end.